Light, camera, action. Okay, so hello and welcome to Ascent Gate Academy. Our next chapter is complex analysis. This is again an important chapter for gate examination. You can expect 1 to 2 marks questions from this chapter. So we'll start with with some of the basic concepts. So our first basic concept is definition of complex number. This we all know from class 11. A number of the form z equals to x plus iota y. X and y are some real numbers. This iota is nothing but root over minus 1. So any number of this form x plus iota y is called complex number. Here this x is called the real part of the complex number and y is called imaginary part of the complex number. Okay, remember that x and y, both of these are some real numbers, and if the number is in this form, then it will be a complex number. Now if x is 0, this means the complex number z is purely imaginary. Okay, any complex number for which the real part is 0 is called purely imaginary complex number. Example will be 2 iota, 3 iota, minus 4 iota. These are examples of purely imaginary complex number because the real part is 0 here. And the second case, if y is 0, if the imaginary part is 0, then z is called purely real. So example of purely real number will be 2, 3, 5, root 2. These are purely real numbers. Okay, so every real number is a complex number whose imaginary part is 0. So this is first basic concept. Now the second one is modulus and argument of a complex number. Okay, second concept is modulus and argument of complex number. So next we are going to talk about this thing, modulus and argument of a complex number. So every complex number can be represented by a point in xy plane. Suppose if the complex number is z is equals to x plus iota y. So this complex number can be represented by a point x comma y in complex plane. Okay, suppose if these are the coordinate axes, then in complex plane this x axis is called a real axis. This x axis is a real axis and this y axis is called imaginary axis. So if the complex number is x plus iota y, then this can be represented by a point in complex plane. So say if this point is x comma y, then modulus of the complex number is nothing but the distance of this point from origin. Okay, this distance OP is called mod z. So the modulus of this complex number, modulus of z, so this will be represented by mod z, and this is nothing but distance of point P representing this complex number x plus iota y from origin. So this will be root over x square plus y square. I mean, this is obvious because if the point is x, y, then this distance is y, this distance will be x. So mod z will be root over x square plus y square. So modulus of any complex number is square root of a square of imaginary real part plus a square of imaginary part. Next one is argument of complex number. So this argument of complex number is nothing but the angle made by this line OP with positive x-axis in counterclockwise direction. Okay, this angle is called argument of complex number. So as you can see that this angle will be argument of complex number z, and this will be nothing but tan inverse y by x. Okay, so this will be the formula to calculate argument. Now obviously if the point is in second quadrant, then you have to use appropriate formula. If the point is in first quadrant, then this will give us argument. But if the point is in second quadrant, okay, let me write this thing here. Argument of z, if the point is in first quadrant, tan inverse y by x. Here this will be pi minus tan inverse mod y by x. If any point is in second quadrant, then this will be the formula to calculate argument, because argument is always angle from positive. If the point is here, then this will be the argument of complex number. Now if you calculate this tan inverse mod y by x, then this will be nothing but this angle alpha, right? This distance will be y, this will be x. So alpha will be tan inverse mod y by x. Now as you can see, this theta will be alpha plus theta will be pi. So theta, which is the argument, will be pi minus alpha. So for a point in second quadrant, this will be the formula to calculate argument. Similarly, in third quadrant, you can show that the argument will be pi plus tan inverse mod y by x, and in the fourth quadrant this will be 2 pi minus tan inverse mod y by x. So in this way you can calculate argument of any complex number. So this was our second basic point, how to calculate modulus of a complex number, how to calculate argument of a complex number. Now next we are going to talk about distance formula in complex plane. So distance formula in complex plane is related with modulus of a complex number. It is related with modulus of a complex number. Suppose if we have two complex numbers, say our first complex number is, our third point will be, the third point will be distance formula in complex plane. Okay, these are basic points that we need to know. So distance formula in complex plane. Complex plane is also called Argand plane. So these two things are same. Either you can call complex plane or Argand plane. So distance formula in complex plane is, suppose we have one complex number z1 which is x1 plus iota y1, and another complex number z2 is x2 plus iota y2. Now suppose these two points are these two complex number are represented by points a x1 y1 and second point b x2 y2. Okay, as we have seen that any point in complex plane, can be any complex number can be represented by a point in complex plane. So suppose if this first point is representing our complex number z1, the second point is representing our complex number z2. Now we all know that this distance formula is, distance AB will be root over x2 minus x1 square plus y2 minus y1 square, right? This we know from class 8-9 that distance between 2 points is given by this formula. Now how to get this distance using complex number? What should be the formula for distance between 2 points using these complex numbers? So see, if I calculate mod z2 minus z1, so this will be mod, if I subtract z1 from z2, I will get x2 minus x1 plus iota y2 minus y1. And we have seen that modulus of a complex number is nothing but a square root of real part plus a square root of sum of a square of real part and imaginary part. So root over x2 minus x1 square plus y2 minus y1 square, right? So this is nothing but distance between 2 points. So now we arrive at one very important conclusion, that this mod z2 minus z1 is nothing but a distance between, okay, this is a very important result. From here we will see equation of a circle. So mod z2 minus z1 is distance between points representing complex numbers z1 and z2, complex numbers z1 and z2. So this is a very important result, and this formula is called distance formula in complex plane. Now we will see how to get equation of circle using this distance formula in complex plane. So that will be, till now we have discussed three basic concepts. The first one was simply the definition of complex number. Then we talked about how to calculate modulus and argument of complex number. Modulus was nothing but distance of point representing that complex number from origin, right? Root over x square plus y square, or you can call that as root over real part square plus imaginary part square. So that was our second basic point, and argument was nothing but the angle made by that line with positive x-axis in counterclockwise direction. And the third point was distance formula in complex plane. Now the fourth point is and this is very important again, equation of a circle in complex plane. Okay, equation of a circle in complex plane. So this equation mod z minus z naught equals to r. Z is any general complex number, z naught is a fixed complex number. So mod z minus z naught equals to r. This represents a circle with center at z naught. Okay, this center will be at z naught and radius r. So this is again a very important result. This is equation of circle in complex plane. And why this is equation of circle? Because suppose if you have a fixed point z naught and this z is a moving point. Okay, this point z is complex number z is represented by point P. Now this distance will be mod z minus z naught, right? And it is said that this distance has to remain constant. So this means this point P can only move on a circle if this point P is anywhere on this circle, then mod z minus z naught, which is nothing but distance between these 2 points, this will remain constant. Okay, so this equation represents a circle whose center is at z naught and radius is r unit. For example, suppose if I write say mod z plus 2 equals to 3. So what is this equation? This you can write as mod z minus 2, this equals to 3. So this is a equation of circle whose center will be at this point minus 2. Now obviously minus 2 is a real number, so it will be on this real axis on negative side. So this will be the center of the center of the circle, and the radius will be 3 units. So you will get a circle like this. This is the equation. This locus is represented by the equation mod z plus 2 equals to 3. Okay. So this was all about equation of circle in complex plane. Now our fifth basic concept will be how to write complex number in different forms. So now our fifth basic concept will be how to write a complex number in different forms. So basically we are going to see 3 different forms of a complex number. The first one is Cartesian form, second one is polar form, and the third one is exponential form. Okay, there are different ways of writing a complex number. So our fifth basic concept, this will be different forms of complex number. Okay, different forms of a complex number. So the first form is called Cartesian form. Now in this Cartesian form, a complex number is simply represented by real part plus iota times imaginary part. Okay, this is the form that most of the time we use. So this form is called Cartesian form. X is real part, y is imaginary part, x plus iota y is our complex number z. Second one is polar form. Now in polar form, the complex number is represented by this formula. Z is cos theta plus iota sin theta. Okay, r into cos theta plus iota sin theta. This r is nothing but mod z and theta is argument of z. So this form is called polar form of complex number, and it is very easy to see that these two forms are same. Okay, suppose if we have some point xy here, now if the complex number is z, x plus iota y, then it will be represented by point xy. Now this distance is mod z, which we are representing by this r, and theta, which is argument of z, is nothing but this angle. So as you can see, this y will be r sin theta and this x will be r cosine theta. So here in place of x, if you write r cosine theta, and in place of y, if you write r sin theta, then from this Cartesian form you can get the polar form of complex number. And the third form is exponential form. This is also called Euler's form. So in exponential form, we can write the same complex number as we all know that this cos theta plus iota sin theta is nothing but e to the power iota theta, right? So this means you can write the same complex number as r e iota theta, and this form is called exponential form of the complex number. Here r is mod z and theta is argument of z. So these are three different forms of a complex number. So this was all about basics of complex number. Now after this we can take some of the questions which were asked in GATE previous year papers based on these basic concepts. Okay, so now we have these three problems on basics of complex numbers. So the first question was this. First question is, this question was asked in GATE 1997. So the problem is the complex equation z plus 1 equals to 1 lie on. Okay, it was given in the problem z is x plus iota y. 4 options are given. Okay, lie on, different options are given. So basically the problem is you have to identify what kind of locus it is. So just now we have seen that mod z minus z naught equals to r. This represents a circle and the center of the circle is at z naught and radius is r unit. So here you can see that this equation is in this form, mod z minus z naught equals to r, right? Here you have the equation mod z minus 1 equals to 1. So this means this will be an equation of circle and its center will be at this point minus 1, x coordinate minus 1, y coordinate 0, because this is a real number, and the radius of this circle will be 1 unit. Okay, so the complex numbers which will satisfy this equation will lie on a circle whose center will be at minus 1 0. So this point will be the center of the circle and radius 1 unit. So you will get a circle like this. Okay, so 4 options were given. So correct option will be this. All the complex numbers satisfy this equation will lie on a circle whose center is at minus 1, radius is 1 unit. So this was a fairly simple question. The second one is, this was asked in GATE 2012, and this is a very interesting problem. See, it is given that x is root over minus 1. Now root over minus 1 is nothing but iota. So the question is, we need to calculate the value of x to the power x. So basically the problem is that we have to find the value of iota raised to the power iota. Now see, in order to solve this problem, we have to write this iota in exponential form. Okay, now how to write this iota in exponential form? So this can be written as r e iota theta, where r is the modulus of this complex number and theta is the argument. So modulus of this complex number, this will be 1. Right, because modulus is root over real part square plus imaginary part square. So this will be 1. And what is the value of theta here? Now we all know that this theta is angle made by this complex number with positive x-axis. So iota will be on imaginary axis. Okay, this point 0, 1 will represent iota. So you can see that this angle will be pi by 2. So this means in place of theta you have pi by 2. So iota can be written as mod r is 1 e to the power iota, theta is pi by 2. So e iota pi by 2, this will represent iota. Okay, and you can easily see that this will be iota because e iota pi by 2 will be cos pi by 2 plus iota sin pi by 2. Cos pi by 2 0, sin pi by 2 1. So now you can write this iota to the power iota as e to the power iota into pi by 2 raised to the power iota. So this will be e to the power iota square into pi by 2. We all know that a to the power m to the power n is a to the power m into n. Law of indices in class 8. So this will give us iota square is minus 1. So this will be e to the power minus pi by 2. So the correct answer for this question will be x to the power x is e to the power minus pi by 2. Iota square is minus 1. So therefore we are getting this minus pi by 2. So these two were very easy question. Now this one is a very interesting question. Here we need some important concept. So the question is, consider this circle. The given circle is mod z minus 5 plus 2 iota. This equals to 2. This is our given circle. So the question is, consider this circle in complex plane. The minimum distance from origin to the circle is. So first let me draw this circle. the center of this circle will be at this particular point. This is your z naught. Z naught is 5 plus 2 iota. So this will be represented by the point 5 comma 2, right? X coordinate 5, y coordinate 2, and the radius of this circle is 2 unit. So we have a point x5 y2, so this will be the point, and radius 2 unit means this height will be the radius. Okay, so you will get a circle something like this, just touching the x axis. So this point will be 5 comma 2, and the radius, since it is touching x axis, because the radius of this circle is also 2, y coordinate of center is also 2. Now the question is, what will be the minimum distance of any point on this circle from this origin? Okay, there are infinitely many points on this circle. Suppose this point is O, take any arbitrary point P. So this distance is OP. Now this point P is free to move on this circle. So the question is, what is the minimum value of this OP? Okay, for example, if the point P is here, then this will be your distance OP. So for different location of P, you will get different distances OP. So what will be the minimum distance OP? So here you need to know one basic concept, that if you have a circle and you have a fixed point outside the circle, then maximum and minimum distance, okay, point is whether outside or inside, this will not make any difference. So maximum and minimum distance will always lie along the line joining the center to this fixed point. Okay, so this means if I join the center of the circle and extend this and say the point P is here, then in that case this distance OP will be minimum, and if a point P is here, then distance OP will be maximum. Maximum and minimum distance will always lie along the line joining this fixed point to the center of circle. So you can write that the minimum value of OP, this will be distance from center, say this point is C. So minimum distance will be distance from center minus radius, right? This distance OP will be distance from center minus this radius, and the maximum value of OP, this will be distance from center plus radius. Okay, so here the question is, what is the minimum distance? So minimum distance will be distance from center minus radius. Distance from center will be root over 5 square plus 2 square minus radius is 2 unit. This will give us root over, this will give us root over 25 plus 4. I think I have made a mistake here. In actual problem this was 5 iota. Okay, so do this correction. Here also you will get 5 iota. This will be 5 iota. The coordinate, sorry, this will be 5. The coordinate of this point will be 5 comma 5, and in that case it will not touch x axis, but that is not important here. So here the center of this the coordinate of center will be 5 comma 5. So here also you will get 5. So now 5 square plus 5 square, if you take 5 common, then you will get 5 into root 2, right? Root over 50, so 5 root 2 minus 2. So this will be the minimum distance from center, which is our option A. So this will be correct answer. If the question was what will be the maximum value of OP, then maximum value of OP will be distance from center plus radius. So this is 5 root 2 plus 2. So this is an important concept that you need to know. If you have to calculate minimum distance, then minimum distance is distance from center minus radius, and maximum distance is distance from center plus radius. So this was all about basics of complex number. We have seen 3 problems on this basic concept. Now we will see complex function.